We're going to be working today with marginal functions in economics and how they apply to the real world. We'll give you three main things to think about and then help you through one of the problems in the book. So let's get started. So we're going to be looking at three important steps or equations that are crucial in order to solve these problems correctly. The first one is marginal cost function, and it's basically the change in cost over the change in the output, or which is the much easier way to look at it, the derivative of the function, or c of x. And we'll go on to explain why all of this works in the end. So the second equation is the average cost function, and we can see that as c of x over x. And the average cost function is also seen in your book as c bar of x. And the final one is the average marginal cost function, and we can read that as the derivative of c bar of x. So we're going to be working through a problem from page 248, and it's number 62. The total weekly cost in dollars incurred by Herald Media Corporation in producing X amount of DVDs is given by the total cost function c of x equals 2.2x plus 2,500. X has to be in between 0 and 8,000. So our first step in finding A is finding the marginal cost function, and we look back at our notes and we find that it's the change in cost over the change in the output. And I know that I said that an easier way of finding this is to take the derivative of the function, and we're just going to kind of show you how it ends up being like that and how it results, because I think that's important. So when you plug in 2,000 into the function, you're going to get 6,900. And when you plug in 1,000 to the function, you're going to get 4,700. So when you find the difference of that, also known as the change in the cost, then you're going to get 2,200. And when you put that in the numerator, divided by the change in the output, which is 2,100, you're going to get 2.2. Or you can just find the prime, or the derivative, but that's just kind of how it works, how it results in that. So we look at the question again. What is the marginal cost when x equals 1,000 and x equals 2,000? So first what we did is we found the marginal cost function, which is the change in cost over the change in the output. So when we plugged in 2,000 to the original function, then we got 6,900. And when we plugged in 1,000, then we got 4,700. So when we put that on the numerator, divided by the change in the output, or the difference in the two x values, which is 2,000 and 1,000, then we get 1,000. So overall, we get 2,200 divided by 1,000. And our math sees that we got 2.2. And I had said before that the easier way to find this value is to also just take the derivative of the original function, which is 2.2. But we wanted to show you how that resulted, and because the marginal cost is basically approximated by the rate of change of the functions evaluated at a specific point. So it makes sense that you would just be able to take the derivative of the function. We'll go back and look at our average cost function equation, and we find that it's c of x over x. So we plug in the numbers in the equations, and it's 2,500 plus 2.2x divided by x. So we basically divide the whole equation by x. So we find out that 2,500 over x plus 2.2. So that is our official average cost function. And if we look back, then we'll find that the marginal average cost function is actually just taking the derivative of that average cost function. So when we take the derivative of 2,500 over x plus 2.2, then we find that it is negative 2,500 over x squared. First thing that we did was we found that the average cost function equation is c of x over x. So we plug in 2,500 plus 2.2, which is the function, and we divide that whole thing by x. and we come up with the average cost function as 2,500 over x plus 2.2. Then in order to find the marginal average cost function, then we find the derivative of that, and we found that to be negative 2,500 divided by x squared. So for part C, we're going to take our average cost equation from part B and use it to find the answer to this part. So in order to do that, we're going to take, we're actually going to use a limit. So when you see as it approaches $2.2 a disc, then that's kind of a hint to use a limit. So we can set it up as the limit of as x approaches $2.20 equals our average cost. So when it's approaching 2.2, it's almost, we're finding those small numbers that it's so infinitely close to 2.2. So we're going to basically plug in 2.2 in for x, and we're going to find that the answer is 1,138.56. So here's a quick little recap of part C. So first we need to find out what exactly we're going to look for. So we show that the average cost incurred by Harold in producing a DVD approaches $2.20 a disc when the level of production is the highest. So when we see that something approaches a number, then that's our automatic hint that it could be a limit. So we wrote that limit of x approaching 2.2, and then we used the 2.2 plus 2,500 over x, which was our average cost function from part B. We used that to set it equal to the cost as x approaches 2.2. So when we solve for that, then we find that the answer is 1,138.56.